Hello, in this lecture I will give you a proof of the Pythagorean theorem. Pythagorean theorem relates to a right triangle like this triangle. A right triangle is a triangle in which you have one angle with 90 degrees. This angle is 90 degrees, and the theorem says that the sum of the hypotenuse, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. So c squared equals to a squared plus b squared. The sum of the hypotenuse equals to the square sums of the perpendiculars. C squared equals to a squared plus b squared. In order to prove the theorem, we actually built a copy of this triangle here. The way that we built the copy is by drawing side B in the same line of side A, and then we actually raise a perpendicular in size of A to side B. So the angle between side A and side B in the in this triangle is 90 degrees. The angle of the angle between sides B and side A in this triangle is 90 degrees. So we have here two triangles that coincides to each other, and I will prove it because these two triangles have two sides that equals to each other. Side A in the left triangle equals to side A in the right triangle, and side B in this triangle equals to side B in this triangle, and actually also the angle between the two sides in this triangle is 90 degrees, and so is the angle between side A and side B in this triangle is 90 degrees. For this reason, these two triangles coincides to each other. And for that reason, this side is side C because it is according to the rule corresponding sides in coincides triangles. So if this side is C, this side is also C, and actually if we label the angle between side A and side C as alpha, this is 90 degrees, this angle, and we can label this angle between side C and side B as x, because of the fact that we don't know what is the size of this angle. We will label it at x, but we do know that in every triangle the sum of its three angles equals to 180 degrees. So alpha plus 90 degrees plus x equals to 180 degrees. As you can see here, alpha plus 90 degrees plus x equals to 180 degrees, because the sum of the angles in every triangle equals to 180 degrees. Now we can subtract 90 degrees from both sides of the equation. So we will get that alpha plus x equals to 90 degrees. Now we will subtract alpha from both sides of the equation. We'll get that x equals to 90 degrees minus alpha. Is equals to 90 degrees minus alpha. Okay, so we can write here x equals to 90 degrees minus alpha. So because of the fact that this triangle coincides to this triangle, and the angle between B to C is x, so the angle between B to C here in this triangle must be also x. Now we also don't know the size of this angle, so we label it as y. But we do know that in every straight line the sum of its angles in one side is 180 degrees. So alpha plus y plus x equals to 180 degrees. And also the sum of a straight line in the other side is also 180 degrees, so this angle is also 180 degrees. So we can say that, we can write that alpha plus y plus x equals to 180 degrees. Alpha plus y plus x equals to 180 degrees, but we know that x equals to 90 degrees minus alpha, so we can substitute x by 90 degrees minus alpha. Okay, we substituted x by 90 minus alpha, 90 degrees minus alpha. Now alpha minus alpha equals to 0, so we can eliminate alpha from the equation. So after we eliminated alpha from the equation, we got that y plus 90 degrees equals to 180 degrees. We can subtract 90 degrees from both sides of the equation. We will get that y equals to 90 degrees. Okay, y equals to 90 degrees. So the middle triangle is a right triangle because he has an angle of 90 degrees. Now you can see here this is a trapeze. Now we will calculate the area of this trapeze in two ways. Then we will compare the results. Of course, they must be the same, and from that comparison we will prove the Pythagorean theorem. So the first way to calculate the area of this trapeze is by saying that first of all we will label the area as S as the area of this trapeze, and the area of this trapeze is equal to the sum of its parallel sides. You see here that A is parallel to B, so it is A plus B times the height of this trapeze. The height of this trapeze is also A plus B, and we divide it by 2. So the area of this trapeze equals to S, that equals to A plus B, that is the sum of the parallel sides, plus the height of this trapeze, that is also A plus B, divided by 2. So this is the first way to calculate the area of this trapeze, and the second way to calculate the area of this trapeze is by saying that the area of this trapeze equals to the sum of the areas of its components. This trapeze contains three triangles, these triangles, and these triangles. So the area, the sum of the areas of these three triangles will be the area of this trapeze. So S equals the area of the trapeze equals to the area of this triangle. The area of this triangle equals to the base of the triangle times the height to this base. So the base of this triangle equals to A times the height to the base, that is B, divided by 2. So the area of this trapeze is A times B divided by 2. The area of the middle triangle equals to the base of the triangle times the height to this base, so it is C times C divided by 2. And the area of this trapeze equals to the base, the area of this triangle equals to the base of the triangle, that is B, times the height to the base, that is A, divided by 2. So in total, the sum of the areas of the three triangles equals to the sum of the area equals to the area of this trapeze, and it is actually equals to the area of the first triangle, that is A times B divided by 2, plus the area of the middle triangle, that is C times C divided by 2, plus the area of the left triangle that equals also to b times a divided by 2. Now, as I already said, it is the same area, the same trapeze. We actually just calculated it the same area in two different ways. And of course, expression 1 is equals to expression 2. So we will make a new equation that says that expression 1 equals to expression 2. So a plus b times a plus b divided by 2. This is the first expression of the area of the trapeze equals to the area of the trapeze when we calculated it by the second way, second expression, e times b divided by 2 plus c times c divided by 2 plus b times a divided by 2. So here the equation says the expression 1 equals to expression 2. The area of the trapeze in the first calculation equals to the area of the trapeze in the second calculation. Now we will multiply the two sides of the equation by 2. We will get that a plus b times a plus b equals to ab plus c times c plus ba. Now a times b plus b times a is a times b plus a times b, that equals to 2ab. Plus c square as I already said, a times b plus b times a equals to 2ab, c times c equals to c square. Now we will open the brackets in the left side. So a times a equals to a square, a times b equals to ab, b times a equals to ba, and b times b equals to b square. That's the left side of the equation equals to the right side of the equation, and the right side of the equation equals to 2ab plus c square. Now BA plus AB equals to 2AB. Okay, now we will subtract 2AB from both sides of the equation. Okay, after we subtracted 2AB from both sides of the equation, we got that A squared plus B squared equals to C squared, and that is exactly the Pythagorean theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C squared equals to A squared plus B squared. Okay, so that is the proof to the Pythagorean theorem. Okay, thank you very much.